What's up my friends, welcome back. Today we have another 3D printer review and this is the longer LK4 Pro version, and if you are interested into buying this kit, well stick around because in this video I will make an unbox, I will assemble it, make a few print tests and show you the results, and also tell you the parts that I like and also the parts that I don't like about this kit. So I hope that this video will help you decide whether to buy this kit or not. So guys, consider subscribing, give a like to this video if this will help you, and also consider supporting my work on Patreon. So let's get started. So here we have the printer. This is the longer LK4 version Pro. Later we'll make the unbox, we'll assemble it and make some print tests with different materials. But first let me tell you some specifications about this printer. Okay, so first thing first, we have a printing volume of 220 by 220 millimeters in the X and Y direction, and we have a height of 250 millimeters in the Z direction. So that's the printing volume. It can go to speeds up to 180 millimeters per second for the movement, but it's recommended to go to 60 or 70 millimeters per second. It has this heated bed, which is made out of aluminum, as you can see here, but you also receive this glass, which on one side you have to print on glass if you have if you want a nice clean surface, and if you want you can print on this build-tag material, which as you can see I had some problems because this is very sticky. Usually this build-tag material, when it gets cooled, it will relax and then you can easily get out the print, but in this case it was very sticky, so I had to apply a lot of force. So you can select, I like this, that you can select if you want to print on glass or on a build-tag material. That's pretty nice, but I prefer the elastic plate because in that way you can remove the print easily. Now the power supply here is a 24 volts one, so everything will heat faster, the heated bed and the extruder, than compared with a 12 volts one, so I like that as well. It uses a Bowden system to extrude the filament. I'm not really a fan of the Bowden system, especially for big printers, but since the distance between the extruder and the nozzle is not that big, it won't give problems due to friction. The heating block here could get up to 250 degrees, and this model uses a 0.4 mm nozzle, and we also have here a cooling fan for cooling the parts while printing. To control everything we have this very nice LCD display which is colored, and this is way much better than the common LCD display, the blue LCD display with the rotary knob. As for the step motor drivers, it uses those very silent ones from Trinamic. These are the TMC2208, so the motors are very silent. But the problem is this fan here. This is the fan that is pushing air inside of the electronic case, and this is very loud. It will create a lot of noise. So let me just show you an example that the problem is not with the electronics and the step motors making noise, but with the fan. So with a simple upgrade, maybe put a bigger fan for $2 or $3, you can decrease the sound a lot, and this will be a very silent printer, and I love that. Oh, and look, this is pretty nice. We also have a heat dissipator on top of the SD card reader, because if you know, the SD card will get quite hot when you have a lot of G-code sending to the machine. So that's pretty nice. So if actually the air is blowing from here, it will cool these heat dissipators and this one as well. So let's make a sound test. Let's power the machine with the fan connected and then home the machine with the fan and home it without the fan, and you will see the sound difference. So let me just power it up, power it on. And as you can see, we can already hear the sound of the fan. So let's just home the machine in the X and Y direction. So this will be the sound of homing the machine with the fan connected. Now let me remove the fan and do the same. So now I remove the fan and let's do the same. We home the machine. Yes. As you can see, you can hear nothing. So the machine is very silent, but the problem is this fan, and also the power supply has a fan below, and that also sounds a little bit. So maybe build a case for the power supply, or maybe change the fans, and that will lower the sound even more, and that's pretty easy to make. Just buy better fans. Let me just place the microphone closer to the step motor while homing the X-axis. So here we have the step motor, and I click home. And that's the sound, almost nothing. Now for the y-axis. And that's it. So the printer could be very silent, but because of the fan of the electronics and another fan inside of the supply, which also creates quite a lot of sound, well, the printer is not that silent, but the motors are very silent. So longer, a future improvement, what I propose, just change for a better fans, maybe a bigger one, which cost a little bit more, just a few dollars, but it will make the printer very silent. And in my case, I love when the printer is silent because I can work in the same room as the printer, and that's very nice. Now the entire frame is made out of metal, so it's very strong and stiff, so it won't vibrate too much. It's not that heavy though, I think I could lift it, as you can see, only with one hand. So I like that. And also what I like about this model is that now it has this smooth surface. So usually you get this debris like this one of plastic, and it will get stuck in those grooves here of the metal. But in this way, since it's flat, that won't happen. So I like that. I like that the body is very strong and made out of metal. All axes have V-rollers, so the movement is very smooth and everything is very compact. As you can see, we have the supply below, the electronic case, this spool holder here, and everything is compact, so you can just move this, place it on your table, and that's it. So you don't have loose wires all around. And that I also like. By the way, this printer is open source, so you can improve it and you can change the code and share it with the rest of the community, so we can all take that code and use it with our printers. That's also pretty nice. The printer also has a printing recovery function, so if you unplug it or maybe the power went down, when you plug it back on, it will appear on the screen that you can continue the print and recover the part, so that's pretty nice because in that way you won't lose the entire part. And together with that we also have this filament detector here at the input of the extruder, so if you run out of filament or maybe the filament break, you can detect that and it will pause the print, you can put back the filament and continue, and all that it will appear on the screen so you can control everything. To print with this printer you have two options. You can use the USB input directly from a PC, or maybe just insert a micro SD card like this one here into the slot and print the files that you have here, so you have to create the G-code and save it on the SD card. And that's usually what I do. The printer is advertised to print with PLA, which of course is the easiest one, but also ABS, HIPS, wood, and also PETG. As for the electronics, as we have already seen, everything is inside this metal case and all the wires are insulated for safety, so that's pretty nice. And the power supply also has at the input a switch and a fuse for 25 amps, and that's also for safety. The board is using the Atmega 2560 as always. This is the microcontroller, and we have the dynamic drivers that we have already seen. I can't see any external MOSFET, so I'm guessing that this is the MOSFET that controls the power to the heated bed or to the extruder. But anyway, the heated bed is not that big, so it doesn't need that much current. So maybe with just a MOSFET on the PCB it's enough. I'm not sure. I hope that this won't give me problems in the future. Okay guys, so let's go and see the unbox of the printer when you receive it. I will assemble it very fast, make a few print tests with the different materials, and then I will give you my final opinion, where I'll tell you what I like and what I don't like about this printer. So let's see the unbox right now. So you receive the printer like this in a cardboard box, and it weighs around 13 kilograms, so it's not that heavy. So let's open it. Okay, so let's see the unbox. So we have the typical protective foam. First we have the user manual and the assembly guide with color photos. We have a print removal tool. Then we have the printing bed, which this one is made out of glass, but I think it has some texture on it. And this is the heated bed. Okay, so we have another level here. This is the entire bottom part of the printer that you can take it out. So guys, this is what you get when you order this kit. You get the main bottom part of the printer, which has the power supply, the main board controller, and the heated bed already assembled. And then you get separately a glass for the heated bed, which also has some kind of surface on it. Then you have the X-axis, which has the nozzle and also the step motor for the extruder. You get the power cord, of course, the LCD display, which we'll mount later. We have a spool holder. This I think is the step motor for the Z-axis that will go together with the lead screw. And for accessories, you get a print removal and you get a print removal tool. You get the SD card and SD card reader, some tools, some end switches and some screws. This is the top part of the printer for the Z-axis. And you also get some sample for a PLA filament and the user manual and the assembly guide. So that's what you get when you order this kit. So now we should assemble it. By the way, about the cardboard box, I like that you get it with these very hard cardboard corners, so the parts inside won't bend. So this is very safety for shipping. So I like that you have this foam, so it will protect everything. In my case, I've checked all the parts and nothing is damaged yet. We'll see that in the assembly process. Okay, so I'll start with step 1 and 2, which is to pass the top frame of the printer through the rollers of the x-axis, and then I have to add the z-axis step motor here on the bottom part of this top frame. Okay, so from what I see from the manual, the smooth part of this should be on the front of the printer, and also for the z-axis, the part with the extruder should be on the front and the part with the step motor on the back. So I think it will go like this. So just roll this in. Oh, that's very smooth. We have the step motor. So there we have the motor. Okay, so step 3, as you can see here, of course, is to add the lead screw between the motor and the z-axis. So there you have it. Now when the motor moves, it will lift the axis up and down. Okay, so now we have the top part of the printer and the bottom part. And of course, part 4 of the assembly is to just merge this part with this part. So we have to put this here in these holes, and we use 4 of these screws and the Allen key, and that's it. The process should just take you a couple of minutes. Okay, so first thing first, I take the upper part and place it here and make sure that it's on top of the holes. And then we take 1 screw and place 2 screws on each side. Okay, so that's it. All it took actually is to fit the top part on the x-axis, and then using just 4 screws, 2 here and 2 on the bottom, you place that and you merge the bottom part of the printer with the top part, and you have the printer assembled. Okay, the next part I will add is the spool holder, and as you can see, it already has the screws prepared. So place it here, tie the screws, and that's it. Okay, now we do the same for the LCD screen. We place it here and we have 2 screws. Actually, this label that I just took out from the LCD screen is for the power supply, so you make sure that you switch it for 220 for Europe, or if you are from United States for 115, because otherwise the power supply might blow up. So they put this on the LCD screen so in order to make sure that you will see it. So now all is left to do is to make all the connections for the step motor, the end switches, the display and the extruder. And as you can see, each cable has a label, so don't worry, this is for the extruder, for the x-axis motor, and so on. So you will know where to plug each connector. Okay, so now let's plug it in and calibrate the bed, and make sure that you use this key, and with the eccentric nut make sure that the bed won't wobble around. Flip the switch. Okay, so the first thing I'll do is to lift the z-axis so I can place the glass. Okay, so now I'll go to tune, place it like this. Okay, now so we can go and calibrate it. So for that we get a piece of paper, leveling. Let's go to point. I also have this PLA spool from Longer, so let me take it out, insert it into the extruder, heat it up, and let's make our first print test. So get the SD card, insert it here on the side, and now we go into print. Yes. And the print should start. So let's see the first print with this printer. I'm not sure if this is a good thing or a bad thing that the print is very stick to the base. Sometimes you don't want the print to get out during print. So guys, I think I found the first problem with this printer. The printing bed material here, the build type material, this one, is very sticky. It took me like 5 minutes to get the print out, and also I had to scrape out the rest of the print with this tool, and as you can see that damaged a little bit the material. Actually guys, it was my mistake with this first print. As you can see, I have some more prints here and I didn't have the same mistake, and that was because the nozzle was pushing against the bed too hard, so the first layer was very low. So all you have to do is to increase the layer height of the first layer and then maybe print with this kind of support here, so you won't have the same problem and you can easily remove the print. Okay guys, so I've been printing all these days. I've been using this printer for like 2 weeks now, and I've made some more prints with PLA, ABS, PETG, nylon and flexible, and I will be showing you these prints separately, each one, in a moment. As you can see, I've made a lot of PLA prints, then some ABS, and I had some problems here and I will talk about that in a moment. This is the only PETG that I have. This in this case is this white PETG, and the printer turned out quite well. Also nylon at high temperature. I think I've used 230 degrees. And here we have flexible, which is not that bad. But anyway, you have to print very slow because since you use Bowden, you can't go at high speeds because we have a lot of friction inside. But let me show you each print separately. Now this here is the first print with PLA, and this was an example that I found on the SD card. I can't say it's a bad print because the layers are very good, but we have these small blobs here as you can see, and I think this was for retraction. And in a moment I'll show another print that I've made, another example. But in overall it's quite good, but not these blobs here as you can see. Then I've made the second print with the same material with PLA, and in this case I've printed on a support like this, on a support base, because otherwise, as you remember, the first print got stuck onto the base because this base is very sticky. But using this base here is very easy to remove the print. And this time I have some small blobs, but not that much because I've used a lot more retraction. So I guess that was the problem. And as you can see, we have very good layers, and this is a very good benching. Finally, using the same PLA material, I've printed these bullets, and this was to test the fan of the printer because as you can see, this is a very thin object. So we had very good layers. Let me just make a zoom here. As you can see here, we can barely see the difference between the layers, and this was printed at 0.25 millimeters layer height. Another print with PLA was the statue, and this is a different PLA material, and once again we have those small blobs. So I'm guessing that I'll have to increase retraction even more, maybe 1 millimeter more. But in overall we have good layers, we have no other loose filaments, and the only problems I can see is that retraction problems because of these blobs. Maybe this is when the printer changed the layer. And finally I've made with PLA these bigger prints. This was made with 20% infill, and this is made in spiral mode. It's just a vase. And as you can see, we have very good details, especially in spiral mode, because here we have no layer change. Okay, so now here I'm printing ABS as you can see, and the error is that the print didn't stick well to the bed, so it's moving around. So let me just lower the level a little bit, increase the temperature of the bed, and print again and see the results. So here I'm trying ABS once again. This is the part that failed. So I've done what I always do, which is lower the level a little bit, increase the temperature of the bed, and also add a little bit of hairspray to the bed so it will stick better. So as you can see now we have good results. So I'll show you the part when it will be finished. By the way, the temperature now of the nozzle is 240 degrees and the bed 90 degrees. And there you have it, we are printing ABS. Okay, so here we have the second attempt of ABS, and as you can see we have some wrap layers, but the print was finished. So I've made it once again, but this time I've lowered the layer height to 0.2 millimeter, and let me show you the final ABS print. This is the final ABS print, and as you can see we have some wrap layers here on the bottom, but the rest was printed okay. So you could easily print ABS with this, but you have to increase a lot the temperature to 240 degrees for the filament, and the printing bed to 90 or 95 degrees, and also keep the same temperature in the room. That's very important. But anyway, I think this looks quite good for ABS. Next I've made the PETG with white filament, and you can see this print turned out great, but we have some very loose filaments, and I think that's because I've increased the temperature too much. This PETG works at a little bit more higher temperature than the normal PLA, for example, and as you can see we have some loose filaments, but the layers are okay in my opinion. Now it's difficult to see because this is white, but these layers here are very good. So on this side we have very good layers, and those loose filaments with a lighter or maybe with a hot air gun, you can remove those. So finally I have the flexible print and nylon. This case was printed in nylon, and this is for a project that I'm making my own case for resistors. And this print turned out quite well. We have good layers. So obviously you can print with nylon, but this is a low temperature nylon. So there are some nylons that should be printed at 240 degrees. In this case, this is only 210. So maybe you will have problems with that, but in this case, I got a good print. And finally, the flexible, remember that this was printed at only 15 millimeters per second. So like 20% of the normal speed. We have some very small blobs here, and this was made when the layer was changed. But in overall, we have good results, so you can print flexible as well. But have in mind that you have to print it with very low speeds. So we start with what I don't like about this printer, and first, well, this is just for the aesthetics, but I really hate this kind of protection tube. This is very hard, it won't bend and sounds awful as you can see. I really like those soft material fabric ones, to cover the wires. So this, in my opinion, this looks just awful and is very cheap. As you can see here, we have the same exact cover for the wires on the back, and sometimes it will get stuck here because it's very hard and it won't bend, and also it sounds awful. So what I really like, I've seen on other printers, is some kind of fabric on top of the wires, and that looks a lot better. So that's one thing I don't like. And on the other side, I'm not a fan of the Bowden extruder, but as I already told you, when it's this short is not a problem, but especially when you have an extruder like this one with no gears. You only have one gear connected to the step motor, so that will give you a very low torque. So sometimes it might skip some steps, maybe it won't have power to push the filament in, so it's better to have an extruder with multiple gears to have more force to push the filament. And finally, another part that I don't like is the fan of the electronics, and maybe also the fan of the power supply, because these are too loud. So what's the point of investing money in using those trinamic drivers for silent movement, when then you place a fan like this one, which is very loud, and it will make the entire printer sound very loud. So my idea is to just place some bigger fans, which will make less noise and also cool the parts inside. Okay, so then for the things that I do like, well, I like all the rest. I like that the body is made out of metal, so it's very stiff and strong, so it won't vibrate. I like the fact that it's using 24 volts, so the bed and the extruder will heat up very fast. I also like the touchscreen, it's quite big, it has good colors and a nice menu. And the best of all, I like the fact that without those fans, this printer is very silent, and that's very important for me, because usually I use this printer here in my workshop, so I want it to be silent because I want to also work inside here, maybe with my laptop, so I don't want that much noise. So using those trinamic drivers is the best for this printer. I also like to have the option whether to print on glass or maybe on the Build-Tech material, but as I showed you before, this Build-Tech material is very sticky and sometimes the print will stick very hard on the surface, so it's a little bit difficult to get it out. And finally, the assembly process is just 5 minutes because everything that you receive is pre-assembled, so you have to add some screws and then add the connectors and start printing in just 5 minutes. And as for the price tag, right now this is like 180 euros, which is not that bad for a printer this big and this good quality made out of metal. So guys, this was my review of the printer Longer LK4 Pro version. I hope that you now have a general idea about this printer, and if you consider buying it, you can check the links below. And yes, I hope that I've helped you with something in order to decide which printer to select. Thank you very much, and see you later guys.